Good morning, I'm Dan Vroman, and I'm going to talk about stress corrosion cracking in fiberglass composites. Fiberglass reinforced composite materials are often used to construct tanks, pipes, and other parts for use in corrosive environments because it's typically a cost-effective and more corrosion-resistant material than many other construction materials, such as most metals. But the glass fibers themselves are still susceptible to environmental attack, especially in acid environments. The structural integrity of these fiberglass components is usually dependent on the integrity of a corrosion-resistant barrier, which is constructed of an outer layer, 0.1 to 1/4 inches thick of 95% resin and 5% corrosion-resistant fiberglass, followed by an intermediate layer of acid-resistant chopped fiberglass with 75% resin, and then those are surrounding the inner part, which will be e-glass. This table shows the weight loss of commonly used fiberglass components in an acid solution, which is not a direct measurement of stress corrosion cracking performance, but it has been shown to correlate with the performance of fiberglass structures made with these types of e-glass in corrosive environments. As you can see, e-glass, it's the most inexpensive type of fiberglass, shows the greatest susceptibility to acid attack, and then there are specialized glasses such as A and C glass, which show performance an order of magnitude better. So typically you'll have outer layer of C glass around the part being primarily composed of E glass. Without adequate protection, these fiberglass components can fail under loads well below their design criteria by environmental stress corrosion cracking when simultaneously exposed to high mechanical stresses and a corrosive chemical environment. This will typically occur faster in components under higher loads, higher acid concentrations, and higher temperatures. Here you can see pictures of a fiberglass tank which was patched incorrectly with a non-acid resistant inner layer, and this resulted in decreased fracture toughness under the heavy loading of the acid and ultimately the failure of the tank. To combat and predict this stress corrosion cracking in composites, one method of non-destructive evaluation used is acoustic emission monitoring, in which high sensitivity transducers are attached to the object and sense the sound waves produced by the cracking of the individual fibers within the object. These transducers can detect sounds inaudible to the human ear, both in volume and frequency, and can distinguish between different failure modes as well as the depth within the composite of the cracking fiber. Because composites tend to fail progressively due to the varying strengths of the individual fibers and then propagate perpendicularly to the failed fibers, acoustic emission monitoring can provide early warning of a developing crack in the overall object before it propagates. Here are my references, and thank you very much.